I'd like to talk about other stuff like the mean electrical vectors. So normally the mean electrical vector during ventricular depolarization, most of the ventricular depolarization is about plus 59 degrees. There is a lot of variation even in a normal heart, but if it's too much to the right or the left, it definitely means that something is wrong. Axis deviation is a very important thing you can catch when there's hypertrophy or some sort of ischemia. Question is, how do you catch if there's an axis deviation? For example, if the axis is like this or even like this, how do you catch this? The readings on the leads are a good idea. So because this is lead 1, then we have lead 2, and this is lead 3. There are other ones as well, but let's consider the easy ones for now. And if we're having this as the unfortunate direction, and we kind of like break this up, and if you want to know what will be the recording on lead 1, this is the direction in which you'll get a positive recording. You kind of to draw and kind of join these points. So this is the voltage that will be registered, and this is the direction. So we will have a negative QRS complex because ventricles of QRS is for the ventricles. So it will be a negative QR probably, because that is the biggest. Now if it's now for the other leads, for this it will basically be this. So this is the average potential. This will be positive on the lead 2, and then if you kind of like talk about this, this is 8. This will also be negative. This is lead 2, I think. So this is how you kind of get an idea of what sort of whether you're getting a positive deflection or you're getting a negative deflection, because this is, if it were in the direction of the axis of a particular lead, it would be positive. If it's against it, it would be negative. And the vector's length is kind of like giving an idea of just how much potential you will get. Normally lead 2 has the biggest, 3 has the smallest. If there is a bit of a disturbance there, that is suggestive of a lot of things.